Hey guys, in this video we're going to pick up where we left off in talking about the atom, and specifically we're going to go in and talk about some different models of the atom and what the atom might possibly look like. Quick review, here's the atom and its atomic structure. We have our protons, neutrons, and electrons. We can see here that we have our protons and neutrons inside the nucleus and our electrons orbiting or going around the nucleus of the atom. Protons are fairly large and heavy when compared to electrons. They have a positive charge. They're found in the nucleus, and they have a mass of 1 atomic mass unit. Neutrons are large and heavy like protons. They have no electrical charge. They're neutral, so they're not positive or negative. They're neutral. They are also located in the nucleus, and they also have a mass of 1 atomic mass unit. Then lastly, electrons. Now, it's important to note that our electrons, they're much different from our protons and our neutrons because they are very tiny, much smaller, significantly smaller than our protons and neutrons. They have a negative charge, and then again, they are different because they are not in the nucleus. They orbit or they go around the nucleus. Our electrons go around the nucleus in various pathways, and again, they have a mass that is significantly smaller than protons and neutrons. Okay, so let's talk about models of the atom, what the atom theoretically looks like. Now, it's important to note here that we do not know exactly what an atom looks like. Atoms are so small, we can't see them with a microscope. We can't see them with other instruments or tools. We know they're there. We know they have a particular structure based upon indirect evidence, based upon tests, based upon other things, but we can't actually see them. So we have models on what we think that the atom might possibly look like. So we're going to take a look at a couple of these models, a couple of these theories of what we think the atom looks like. The first one we have here is what we call the Rutherford Model, and it's named after the scientist that discovered it, okay, Rutherford. Okay, and in this model you can see that we have a nucleus. Now the nucleus is a positive nucleus, but it really doesn't distinguish between protons and neutrons. It's just this positive mass in the center of the atom. We do have our electrons, and electrons go around the nucleus in some sort of fashion. They orbit or go around the nucleus. And they're just kind of scattered outside. We don't know their exact pathways, but we know they're out there. They're somewhere outside of the nucleus. So this is called the Rutherford Model. Now, later on, other scientists built upon this model, and one was Niels Bohr, and this is the Bohr model of the atom. And he went on a little bit further to distinguish between our protons with our positive charge and then also our neutrons with our neutral charge. So now we still have our nucleus, which is here in the center, but he also identifies protons and then our neutrons. Instead of just having one positive mass, one positive nucleus in the middle, okay, we have different particles in the nucleus, protons and neutrons. And this is a model that we use a lot, we still use a lot today. To study atoms. Also, you'll see that he has electrons, okay, and electrons are going around the nucleus as in the other models, but in this model it's important to note that the electrons have a definite pathway, okay. The electrons move in definite orbits around the nucleus, okay. We have a definite pathway. That's why we use a line and can identify pretty much exactly where they are. So this is the Bohr model of the atom. Okay, now going on a little bit more with the Bohr model of the atom, and we're going to use the Bohr model of the atom a lot as we study the atom. In the Bohr model of the atom, we said that the electrons have definite pathways. Okay, they are in definite locations, and we call these locations or these pathways, we call them shells, okay? We call these pathways shells. So you can see here that we have a couple of different pathways or shells outside the nucleus. So we've got our protons and we've got our neutrons inside of the nucleus here, and then we've got our electrons going outside in these definite pathways in these shells. And to go even further, we've broken down our shells into different levels and the number of electrons that we can have in each shell. So in this first shell, you can see that we have up to 2 electrons. Okay, so we have this first shell can hold up to 2 electrons. Now, it's important to note not all atoms have 2 electrons. For example, the hydrogen atom only has 1 electron. But in this particular shell, we'd have up to 2 electrons. Now, if an atom had more than 2 electrons, it would go into the next shell. And the next shell can hold up to 8 electrons. Okay? So if the atom has 3, 4, 5, 6, 7, 8, 9, 10 electrons, 2 of those electrons, again, would go in the first shell, and the other 8 would go in the second shell. And then in the third shell, we could also hold 8 electrons. Okay? So again, if an atom has more than 10 electrons, it's going to have electrons in that third shell. So, depending upon how many electrons an atom has, it could have various numbers of electrons. If it has 2 electrons or less, they'll be in the first shell. If it has 2 electrons to 10 electrons, okay, 8 electrons will be in the second shell, 2 would be in the first shell. If it's going to have 11 electrons to 18 electrons, 2 electrons in the first shell, 8 electrons in the second shell, 8 electrons in the third shell. Okay, so we call those shells and the different layers and different orbits of those electrons going around the nucleus. Now, another thing going along with our shells and where our electrons are located are called valence electrons. Now, valence electrons are these electrons in the outermost shell. It's the number of electrons and the electrons we found in the outermost shell of the atom. So if we look at our little example here, we can see that we have in our first shell 2 electrons, 1 and 2. Oops, 1 and 2. And then we have 8 electrons in our second shell. 1, 2, 3, 4, 5, 6, 7, 8. So far we have 10 electrons. Now this particular atom has 11 electrons. So the first shell is full with 2 electrons. The second shell is full with 8 electrons. We still got 1 more electron left. So that electron is going to go into the third shell. The third shell right here has 1 electron, and we call that a valence electron. Now it could also have 2 or maybe even 3 or even 4 electrons. It doesn't matter. The electrons in the outermost shell are our valence, what we call our valence electrons. Okay? All right, now going on real quickly, talking about the third model of the atom. We call this the modern model of the atom, or the electron cloud model of the atom. Now, this still specifies that we have protons and neutrons in the nucleus. But what this shows us is that the atoms, the electrons outside of the nucleus, the electrons out here, we don't know exactly where they are. We know that they are out here and they are going around the nucleus in various pathways, but we really don't know their location. Whereas in the Bohr model, we knew their exact pathway, we knew their exact location. Out here, we're just assuming that they're out here in this cloud area, but we don't know exactly where they are, so we just call it a cloud. They're up there, they're in there somewhere, moving about, moving around the nucleus in this electron cloud. Okay, so we have the Rutherford model, we have the Bohr model, and then we have the modern model, or the electron cloud model of the atom. And most of the time we'll be using a combination of the different models, because the different models do show us different information about the atom and important to know. All right, need to go back and rewind, make sure you are good in your understanding of the different models of the atom.